All right, I'm going to go ahead and go over lesson 2.2, inductive reasoning. The goal of this is to become familiar with inductive reasoning and to use inductive reasoning to find the next term in a number or shape pattern. There are two vocabulary words, inductive reasoning and conjecture. Launch. Sketch the next figure in this sequence. How many squares will be in the 50th figure? Describe the sequence in your own words. The answer is 2600. In each figure, the number of columns is 2 greater than the number of rows. The nth figure would have n rows and n plus 2 columns, with the total number of squares equal to n plus 2. So the 50th figure would have 50 times 52, or 2600 squares. In each figure, the number of columns is 2 greater than the number of rows. Oh, wow. That's interesting. Clever. As a child, you learned by experimenting with the natural world around you. You learned how to walk, to talk, and to ride your first bicycle, all by trial and error. From experience, you learned to turn a water faucet on with a counterclockwise motion and to turn it off with a clockwise motion. You achieved most of your learning by a process called inductive reasoning. It is the process of observing data, recognizing patterns, and making generalizations about those patterns. Geometry is rooted in inductive reasoning. In ancient Egypt and Babylonia, geometry began when people developed procedures for measurements after much experience and observation. Assessors and surveyors used these procedures to calculate land areas and to reestablish the boundaries of agricultural fields after floods. Engineers used the process to build canals, reservoirs, and the Great Pyramids. Throughout this course, you will use inductive reasoning. You will perform investigations, observe similarities and patterns, and make many discoveries that you can use to solve problems. Inductive reasoning guides scientists, investors, and business managers. All of these professionals use past experience to assess what is likely to happen in the future. When you use inductive reasoning to make a generalization, that generalization is called a conjecture. Consider the following example from science. A scientist dips a platinum wire into a solution containing salt sodium chloride, passes the wire over a flame, and observes that it produces an orange-yellow flame. She does this with many other solutions that contain salt, finding that they all produce an orange-yellow flame. Make a conjecture based on her findings. The scientist tested many other solutions containing salt and found no counterexamples. You should conjecture. If a solution contains sodium chloride, then in a flame test it produces an orange-yellow flame. Like scientists, mathematicians often use inductive reasoning to make discoveries. For example, a mathematician might use inductive reasoning to find patterns in a number sequence. Once she knows the pattern, she can find the next term. Consider the sequence: 2, 4, 7, 11. Make a conjecture about the rule for generating the sequence. Find the next 3 terms. Look at the numbers you add to get each term. The first term in the sequence is 2. You add 2 to find the second term. Then you add 3 to find the third term, and so on. You could conjecture that if the pattern continues, you always add the next counting number to get the next term. The next 3 terms in the sequence will be 16, 22, and 29. In the following investigation, you will use inductive reasoning to recognize a pattern in a series of drawings and use it to find the term much further out in a sequence. Look at the sequence of shapes below. Pay close attention to the patterns that occur in every other shape. What patterns do you notice in the first, third, and fifth shapes? What patterns do you notice in the second, fourth, and sixth shapes? Draw the next 2 shapes in the sequence. Use the patterns you discover to draw the 25th shape. Describe the 30th shape in your sequence. You do not have to draw it. Okay. The odd-numbered shapes are all half-shaded circles. Each circle is rotated a quarter turn counterclockwise from the previous circle. The even-numbered shapes are polygons with consecutive odd numbers of sides. There are 3 small circles in each. The 2 on the bottom are hollow, and the centered one on the top is solid. The 30th shape is a 31-sided polygon containing the triangular pattern of dots, and the 25th shape will look like the half circle shaded on top. Are all conjectures that arise from inductive reasoning true? Why? No. Inductive reasoning involves making conjectures that generalize from observed patterns in data. In mathematics, a conjecture is not considered to be true until it is verified by proof. Use the rule n squared minus 1 to generate the first 5 terms of a sequence. What is the 100th term? Answer: 0, 3, 8, 15, 24. The 100th term would be 9,999. Mr. Ross leaves for work at 7 a.m. and is on time. Use inductive reasoning to make a conjecture about Mr. Ross. Mr. Ross will always be on time if he leaves at 7 a.m. Wow. That concludes lesson 2.